Okay, so let's I just want to actually check something here real quick. See. I want to see how well. Um, all right, we'll test this here for a second. Um, if you're a Mac user, your machine already has GCC on it, has a C compiler. Um, Otherwise, you need to look for other resources. Like sometimes I'll tell people to use Cloud9. So Cloud9 is something I use in one of my other classes. That is a hosted Linux operating system. Or if you install Linux on one of your machines, you'll then have a terminal. If you're on a Mac, you'll have the terminal here. You see me working in the terminal earlier today. So if I do like a VI, I'm going to start from scratch here. So let's do, so VI is a text editor. It's just an old school Linux, old school Unix text editor. You probably, if you want to be cool and have nerds worship you, learn VI. Okay? If you want to be practical, don't use VI. You use VI?
I've used VI at times.
Yeah, I love VI.
But I've used VI. I mean, it gives some colors. Now it doesn't give even colors, right?
No.
There's not Java. Yeah, and it's an improved version.
Oh yeah, no. Who uses Vim? Linux users. No, this has more to do with the eras we grew up in. I have a few more miles on me than him. When I started, all we had was VI. there wasn't an upgrade. And then you had the way you've heard of Nano, right?
Oh yeah,
You use Nano. Do you know? So the backstory. You know where Nano comes from? So Nano is the text editor for WIMPs.
Okay.
First of all, that's the one you use.
I don't know.
So the backstory is so I mean, this is similar to what we're talking about a lot of today, where if you learn with newer technologies, you kind of take for granted what you have. So when you came up through this technology, I kind of grew up at the right time. Okay. Because I was right there towards like the beginning of computing to now. So I've lived the whole streak. So I mean, I guess I lucked out from a computer science perspective, but then you also get kind of stuck in some of your old ways. I still like VI. In fact, the thing I don't like about VI on this machine is the newer MacBooks don't have a physical escape key. And VI uses commands, and you hit escape before you type in your command. So I have to use my little magic bar up here to get to the escape key. But in any case, the Nano text editor actually wasn't a text editor in and of itself initially. Back in the early days of email, you had a Unix email client called Pine. A Unix email client called Pine, and all text-based. This is before graphic user interfaces. All right, the text editor built into Pine was a text editor called Pico, and then people got used to using Pico because it was friendly. Like VI is not that friendly. Once you get used to using VI, if you you do touch typing, you basically never have to take your hands off the keyboard. So VI can be very quick for that. But most people, that's not real comfortable for them. So Pico was very nice for Pine because it allowed you to hit backspace and not getting weird symbols and things like that. So then what they ended up doing is they ended up breaking out the text editor from Pine and called it Nano. So Nano is the old Pico text editor from the email client called Pine. Okay. Coward. So make you do all your homework with a chisel and stone. Every ran out of soda. It's very sad. Okay, so let's go ahead and write a little C program, and then we're going to test it on that other thing. So we're going to do let's call this guy practice.c. All right. So I'm going to start a program. So I'm going to do include all right, and then I'll just do a printf. All right, so this is our hello world program in C. Just test this guy real quick. Oops, sorry. What row? Oh, thank you. All right, then that gives me an executable called a.out. You could make it give you a better executable name, but that's the default one. And there's my hello world. All right, so that's hello world in C. Let's just see if that translates nicely over to that web page thing I was messing with over here. Oh, is it a separate? Oh, that's super helpful. All right. All right. How do I run this guy? Run? Probably hit run. Aha. Seemed to work. Okay, I'm happy enough with that. Okay. So in any case, let's do some more samples on here just to make sure so you can do it for yourself when you're doing stuff. Let's see what happens if I hit save. Oh, interesting. So you can, here I'll log in with my Google account. I just want to see how saving works, because one downside of using some of these online online things, so it's called CSC548. Okay. What other languages can I use in this? C. Oh, very nice. All right, so one thing you might do, because I'm not real confident how the saving might work, is if you don't have your own Unix terminal somewhere to do your GCC stuff, and you're going to use this to make life easier for you, maybe every little bit, copy everything and just paste it in some text editor and save it, just in case you accidentally close the tab on your web browser or something like that and lose your whole program. So I'm guessing you can download the code too. I can click on new file. So that's main.c. If I come back to this page, okay, that's their version of the code. So can I open up
Go to your projects.
my projects? Oh, I think I'll be all right. Here, just so I don't forget this. Here, I'm gonna start with the. That's actually a pretty good tool. I mean, you wouldn't write large applications and stuff on that, but I mean, for what we need it for, I think that's going to work out quite nicely. In fact, I may actually use that for my 450 class as well. Although the 450 class, we're rewriting a web server, so we really need it needs to be live. So not going to fly in there, but it'll work for us. Because we're only doing this for a little bit, then we're going to do some ARM programming. It's going to be just do a web link, online C compiler, let's just say. All right, so there, that's up there. So if it make your life easier. Oh, it's on this tab. All right, so I'll go back to my projects. We'll reopen this thing. Yeah. Very happy with that. Okay, so let's look at C a little bit here. I'm guessing I can slide this over. Oh. All right, whatever. Okay, so as a starting point, we looked earlier at, let me just open up my terminal here, close this guy, do a VI, what was that, test.java. Yeah. Okay. Well, actually, we don't need that line up there either. Just want to keep it as like compressed as possible. All right. So here is the Hello World program in C versus Java. All right. So two high-level languages. Both these guys are high-level language. C is a couple minutes earlier. Okay. So what year were you born? 92? All right, so he's like Java. I'm like C. So this is me over here. He's the newer model down here. All right, so 92. He's older than you, isn't he? What year were you born? Oh, 93? Oh, I thought you were even younger than that.
Oh, really?
Yeah. Well, maybe I, because I thought you were like 22 or something like that.
Yeah, but I'm 93 November, so that's almost 94 early.
Yeah. So well, actually, the issue here is that what I perceive as somebody being 22 or 23, I'm thinking they're born in like the 80s. No, born in the late 90s rather. Earlier 90s means that I'm getting older. The distance, it's terrible. All right, so in any case, this is a much newer language. This is the language it was based off of. So all these languages came from C. So at a glance, these guys should look pretty similar, right? They should look fairly similar to each other. All right, so notice that both of them have something called main. So something I'll often say is all programs, all C-based programs begin and end with main. All right, now, main for Java returns a void. So this is the return value of that function. Where main in C, traditionally, it can a modern compiler will actually allow you to return void, but let's just say traditionally returns an int. Why do you think C programs historically return an integer where Java programs can't return an integer? They return a void. Why might a program want to return a value?
There's a result.
See, okay, so what might a result look like?
An error or a product.
Okay.
Based upon what the code's doing.
Yeah, so it's actually good because the issue here is, especially with younger people today, you've only ever worked with graphic user interface type applications, right? In general, the younger you are, you've only ever had Windows. You double-clicked on Microsoft Word and you had a pretty thing show up. Okay, so the fact that you're saying like the return value, error codes, things like that's good because that's really where these things came from. Historically, you were using command line for everything. You didn't have. So if you wanted to have a system call, you wanted to run some program from the operating system, and you wanted to know whether it worked, you would look at its returned value to see whether it functioned. Whether it's, if you wanted it to create a new user account, you might want to check afterwards to see if the user account was successfully done. So you knew whether to go on to the next user, something like that. All right, so that's why it returns an integer, kind of traditionally. Now, the parameters here in Java, these are for command line arguments. All right. So this is taking in a string array called args. You can name this guy whatever you want. You can call that elephants if you want, but it has to be a string array. So this is going to be a collection of anything you send in from the command line in Java. And that's not going to be real common for us because in Java, a lot of times we are running that inside of a graphical application or something like that. We're not actually typing from the command line, running it and feeding it, 5 or 6 different command line inputs. But that's what it's there for. It was far more common to have command line inputs in C. Right? Because back then, most of the things you see me type today at the command line is me calling C programs, feeding a command. Like when I say vi space test.java, vi is a computer program written in C. The command line argument I'm giving it is test.java. It's going to the file system, looking up test.java, reading it in, putting it on the screen here for me to edit it. That make sense? All right, so in any case, Java, we have this string array called args. That's my command line arguments. Now over here on C, we have 2 different parameters coming in here. These are also for command line arguments. So we have int argc and char pointer argv. Why do you think we need 2 in C?
How many strings we
Okay, why do we need to know how many? I didn't need to know how many in Java, did I?
have? Because this is a string type that is a character.
Okay, well, what does it mean? Well, this is a string array. This is an array type. This is also an array type.
Pointer pointers.
Before, the memory might get not, the memory might have an alternate in Java, the base state of the memory, and here specifying the size might not lead to the memory destruction. Maybe that might just take away and give us the garbage.
Okay, well, so keep in mind that Java is a much newer language, right? So we're looking at arrays in both of these, so collections of things, right? All right. Now, at the end of the day, when we say char pointer, we're talking about strings, right? Just because it's not called a string, it's a string. Okay. Over here, we're saying the word string, but both of these are array types. But Java being a newer language, the arrays have kind of evolved. In Java, an array can report to you how long it is, right? So in Java, I can say args.length, and it will tell me how many strings are in there. In C, arrays can't do that.
It doesn't know.
They can't report how many things are in there because you have direct access to memory. So this is kind of similar to we looked at when we saw the assembly language earlier, where we had to load hello world as well as how long it was. Okay, both those pieces of information are important. Because when you load in the message, all you're doing is saying, where does it start? And we're going to see that here in a few minutes. So you're saying, where does that start in memory? And then you're saying, how long do I keep dancing until I'm out of that stuff and diving into like other garbage and things like that, somebody else's data, because I'm still in memory. All right.
So what is technically the ARGC and the ARGV? Are those just very?
This is arg count.
Oh, arg count. Okay.
And arg values. Okay. And then, printf versus system.out.println. That's just a thing. Notice I had to throw a little carriage return here, the \n here. That's equivalent to the ln there on that. The println function goes ahead and presses enter for you at the end. Okay. But largely, we can see that these guys we see the family resemblance between these 2 languages, right? Pretty similar languages. So you feel a little better now, Edwin? C looks enough like, have you worked with C before? So does it look enough like Java that you'll be able to make it? Oh man, just wait. This is going to be so much worse in a couple minutes. All right, so. So we're going to go out of our way when we're working with C here to really work with memory directly. Because I want us to get in the mood of directly working with memory. Because when we get into doing assembly programming, we're going to be directly working with a lot of memory. So we want to be used to that. Okay, so the last couple of classes we've been kind of converting things, working with a lot of numbers, kind of getting a feel for some of the number bases we're going to be working with. Okay, now we're going to start working with memory at a little bit more intimate level. Okay, and then we're going to be directly hanging out with memory when we're working with the assembler. All right, so what I want to do here. So first of all, and this is for those of you who have, this is a question for if you have not worked in C, or at least not worked in C extensively. I have a feeling that these are going to be pretty easy concepts for you. When I say pointer, what am I talking about? So it's, yeah, so it's a variable capable of holding a memory address. Okay? This isn't dissimilar to me asking what's an int. An int is a variable capable of holding a whole number, a signed whole number, right? So pointers are variables capable of holding memory addresses. Now, in languages like Java, often textbooks will say pointers do not exist. Is that a true statement? You think in Java pointers don't exist?
That happens behind the scenes, you just don't see it.
That's it. So it's incorrect to say pointers don't exist in Java. In actuality, is in Java, most things, since Java's making those decisions for you, we referenced that earlier today, most things in Java are pointers. We saw earlier, I printed out the value of R when I created R, random R equals new random. It was a memory address, right? Pointers exist. Most things in Java are pointers. At least the things that should be pointers are pointers because Java makes that decision for us. What Java actually lacks is Java doesn't have a specific syntax for working with pointers. It's not that they don't exist. They just haven't given you the tools to directly manipulate memory. Okay, does that make sense, the difference there? Now, in a language like C, though, we have those tools, Edwin. We have the tools. We have the technology. Oh, you're going to love this. All right, so we're going to say int a is equal to 5. And then I'll do a printf a is %d a, so I'll kick it down the line too. All right, so printf allows us to have formatted strings. So this is going to say a is followed by a space, and then %d is a placeholder for a decimal value. And a is a decimal value. So this guy should print out a is 5. Make sense? Oh, hold on, that's not how I save. How do I save here? Control S. And then I'll go, oh, that didn't seem to actually work, but whatever. All right, so I'll run this. There's my A is 5. All right, cool with that? All right, so now I'm going to say int pointer B. So I've created a variable named B capable of holding the address of an integer. This guy is going to equal the address of A. Okay? That's the special syntax that Java does not have, that C does have for working with pointers. Make sense? All right. Actually, if you want, on that white box up there, will you hit the third button from the top? That should turn this light off. All right. Now you can see the smaller text a little better. Yeah. All right, everybody can see it good now, ish. So I can't really adjust the size of this font. It appears. Yeah. Oh wait. Oh no, that's tabs. Oh, font size. Large. Editor mode, whatever.
No, that's fine.
Okay. Just roll with it?
Yeah.
Okay. As you think I'm asking for you.
I'm the one that needs the most help on this.
These have old eyes. You can see this better than I can, I promise. All right. Yeah, I wear trifocals, so I have contacts in, but yeah, I grew up, because I grew up in that time, most of the computers I sat in front of for hours and hours were tubes.
Okay.
If you've ever seen them on TV, if you've seen somebody with an old school monitor through a video camera, you see the line going down through there, but you don't see it when you're sitting in front of it, right?
Yeah.
Your eyes do. So the focusing muscles in my eyes don't work. I burned them out from sitting in front of the computer so long, yeah. Yeah, so my eyes are actually quite healthy. They just don't work that great. There's no tread left on the tires. What are you going to do? That's why I golf and go to the movies now. I don't do this stupid stuff.
Yeah.
This is your job.
Burnout.
Yeah, burnout. Well, now you have active matrix. You're going to be fine. You should probably pick up skeleton or luge or something if you're going to do some damage. All right, so I'm going to create a variable of type integer pointer. So this guy knows how to hold the address of an int. And what I'm going to put in there is the address of A, the little ampersand thing there. Okay? So A is %D. B is %P is the placeholder for a pointer. So I'll go ahead and put B there. So the first variable here will get replaced with the %D. The second one will be replaced the %P. The value that lives inside of B is a memory address. The value that lives inside of A is a value. So this should say A is 5, B is some memory address. So go ahead and run this. So A is 5, B is some memory address.
And P is what is P?
Pointer.
Pointer.
It's a placeholder for a pointer. Yeah, this is just basically the system that out.println in C it uses a formatted string. You can actually do this in Java, by the way. Java has a formatted string output. But if you came from C or C++, you would have liked this. But yeah, this allows you to build up strings without doing crazy concatenation. Okay, now if here I want to say the address of A is %P, and the value I'll put there is the address of A. And then the value of B, so I'll say star B, the value of B is %D, and the value at memory address B is 5. Okay, so when I so this is that specific syntax for working with memory. So I know B is a variable of type integer pointer. So B holds an address. So star B says the value at that address. Make sense? All right. So similarly, A holds a number because its type is int. So at or ampersand A says, give me the address where that value lives. And that guy will be a pointer. So that's why my placeholder is %P here for the address of A. And my placeholder is %D here for the value of B. Make sense? All right. So this is going to give me crazy memory address and then a 5. Make sense?
Did you need the and sign before A?
This guy here?
Yeah.
That's just text. I could have put LOL there.
Oh, okay.
Yeah. Yeah, this is just for human eyes, only for us to have some sort of semblance of what's being printed out.
I'm sorry, what was the percentage and what does that mean? It means,
This guy here?
yeah.
So in printfs, The percent symbol is placeholder. So yeah, so percent P is a placeholder for a pointer for a memory address. Percent D is a placeholder for a decimal value.
Gotcha.
Percent C is a placeholder for a character. Percent F is a placeholder for a float.
Okay.
Okay.
I'll just look those up.
Yeah. And you actually probably won't need too much of that for your homework. I want you to kind of work with C, so it's going to be a little bit of a foreign language for some of you. He'll get a pretty easy week. But more importantly, you're going to be working with memory.
Okay.
So that's really, I want to put you, so the C thing is more just extraneous. I just like bouncing between technologies because it makes you better. But, you know, I really want you just working with memory addresses, and C is a great tool for forcing you to do that.
Okay.
All right. All right. So this makes sense to everybody? So if we're going to summarize this, we would say something like this. In C, asterisk says, give me the value at an address. Where ampersand says, give me the address of a value. So ampersand lets me extract the address. Asterisk, or star, allows me to extract the value given an address.
They're kind of opposites.
Yeah, they invert each other. And we actually just saw that, right? You know, when I printed out A is 5. Where ampersand A is the address of 5. When I printed out B was a memory address, because B is an integer pointer. Star B is the value at that address. That's why I got the 5. All right, so we're good with that so far? Easy stuff? Oh, it gets so much worse, Edwin. All right, so let's have some fun here. So we're going to go ahead, and hopefully it gives us standard lib. So I'm going to include standard lib.h. All right, so we have a standard library here in C, and this guy's going to give us access to some cool stuff. All right, so now, just for the sake of your homework, you are not allowed to use array syntax in your homework assignment. You have to do pointer math. And you'll see what I mean by that in a second. All right, so what I mean by that is something like this. If I said, if I want an array of 50 integers, let's say, I could say something like int AR 50. And that'll give me an array of 50 integers. That's not what the cool kids would do. Okay. And Edwin, you're a cool kid, right? Yeah. Cool kids wouldn't do that. Cool kids would say this. They would say, I want an int pointer called AR. And I want this guy to be equal to malloc 50 times the size of an int. Memory allocate. We're allocating memory. Malloc is like the new keyword. We saw the new keyword a little bit ago in Java. Malloc is like that. Except the new keyword knows how much memory it needs to get you. Malloc requires us to tell him how much memory he needs us to give him. And why is that? So let's look at memory here for a second. So let's assume we're working in Java. I'm going to say int array AR is equal to new int array 5. Let's say something like that. All right. So this is going to go and create me some new memory, enough to hold this many of these guys. Make sense? Okay. So, and what this is ultimately going to do is it's going to give me something that looks like this. A little bit bigger. All right, so it's going to create for me a variable called AR, which is going to hold a memory address. That memory address is going to point to the beginning, the address of the beginning of that array. Okay, so this is similar to what we saw in the assembly language earlier, where we had message was equal to hello world, and then we needed to know the length, because the value that message actually held was what's called the base address of that string, of that character array. All right? So AR holds a memory address, which is the base address of this array. All right? Arrays exist inside of contiguous memory, memory right next to each other. All right? So these guys is memory right next to each other. Now, the reason I've said 100, 104, 108, 112, 116 here, I assume the base address was 100, just because it's a nice friendly address for us to work with. All right. The size of an integer in Java is 32 bits, or 4 bytes. Okay? So the first integer, the space, so this is the bucket that will actually hold the value. I haven't even put a value there yet, right? I just built the structure. The first integer will live at memory address 100. So it'll take up all the bits between 100 and 103 for bytes. So 100 to, and then 32 bits in. Next one will be at memory address 104, 108, 112, 116. Now when we access arrays, if I want bucket 0 of that array, we know that's at memory address 100, but how did we figure that out? Well, we went to the base address, AR. We added to it 0 times the size of an int in this case, which means go to base address 100, add to it 0 times 4, which is 0, which says bucket 0 lives at memory address 100. Bucket 0, memory address 100. If I say AR at bucket 3, that means go to the base address AR, add to it 3 times size of int, which is 4. So that is 100 plus 3 times 4, which is 12, which is 112. Bucket 3 lives at memory address 112. See how that works? So everything is an offset off the base address of that array. Got it? So Java hides all those details from you. Java doesn't let you directly manipulate memory. Java just says, hey, you want bucket 3? I'll give you bucket 3. This is what's actually happening under the hood. It's going to the beginning of that array, that memory address, and then walking three int size steps from that base address to get you to the third element.
So if your int was size 2, then you'd be taking 2
Size of 2, yeah. If your int happened to be 2 bytes.
And the green is int.
Green is how arrays are indexed.
Okay.
So regardless of where this guy lives in memory, bucket, the first element will be bucket 0, second element will be bucket 1, bucket 2, bucket 3, bucket 4. But I just showed you it doesn't matter where it lives in memory. This stuff makes it easy for humans to work with it. But the way it's actually working under the hood is we're getting the base address and then working off an offset from that to get us to the correct memory location of our value. Because ultimately that's what computers do. They're going to grab you a value from a memory location. Make sense? Okay, so that means if I want to go ahead and I'm going to fill this guy up, so I have 50, so I said I want enough memory to hold 50 of these guys. So that's going to go out and get me a chunk of contiguous memory capable of holding 50 of those guys. Okay? Now I'm going to go ahead. I'm going to fill that guy up with some random random information. I think that's in standard lib, isn't it? I need to cheat for a second here. Sorry. Yeah, it's in standard lib. Okay. So I'm going to go ahead and I'm going to fill this array up with 50 random integers between, let's say, 0 and 100. Okay? So I'll say int I is equal to 0. Well, actually, I could just start it off at int I. And I can say for I is equal to 0. I is less than 50 because that's the size of my array. I plus plus. Now, this compiler, since it's probably newer, would have let me define I inside that for loop, but original C would not have let you do that. Original C did not support a scope attached to a for loop. Okay, unimportant to what we're learning here, right? But I'm writing it in kind of original C. Just you might get a warning depending on where you're doing your thing. You won't get a warning if you write it this way. Okay. So I'm going to go ahead and I'm going to fill up this array with some stuff. Now remember, not allowed to use array syntax. We're going to say I want to put in this memory location this value. Okay, so we're going to say I want to go to the value at memory location AR plus I times the size of an int. See, that closes the int, that closes that, that closes that. And I'm going to set that guy equal to whatever is returned from my function rand mod 101. I think that'll give me a number between 0 and 100. Okay? Then if I want to prove that this worked, I'm just going to steal this for loop again here. And I'll go ahead and do a printf %d, because I'm printing out a decimal value. I'll kick it down the line after each one. And what I want to do is I want to print out the value that lives at base address AR plus I times size of int. That ends that, that ends that. Okay. So I'm going to go through 50 times again. So this for loop fills it up with random numbers. I could have printed them out right afterwards. I'm just doing it a second time to show you, some examples here. So now I'm going to go through every element of my array. Each time through, I'm going to print out a decimal value. What decimal value? The decimal value that is the value at the following memory address. What address? Well, start off with a base address AR. Add to it whatever the current value of I is, times whatever the size of an integer is for this on this platform. And that will take me to the correct place in memory for the next thing. And I want the value that lives at that place in memory. Make sense? So I'll go ahead and save this guy. I'll go ahead and run this. So there's a bunch of random numbers between 0 and 100. Make sense? Okay, so 2 things for your homework. Thing number 1, I'll give you our current code as a starting point. I'll put it up on Slack. I want you to implement an insertion sort in C. that will sort our 50 numbers, or if you want to change it to 100 numbers, it doesn't matter how many numbers you have. We'll sort those numbers in ascending order. Now, you have to write your own insertion sort. You can't use a built-in sorting function. So 2 rules. You got to write your own insertion sort, and you could only use pointer math. No square brackets anywhere in your code. Square brackets equals automatic 0. Get it? No square brackets. Pointers, 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 pointers. All right, so that's one part of your homework. The other part of your homework is going to deal with the book. So now, what have I had you read so far in the book? Have you done chapter 1? Have I actually assigned you reading yet? Okay, so go through all of chapter 1 and do the all the interactive exercises. All right, I'll be able to see that you've done them on there. There's this thing here at the end. These are like homework exercises. Don't do any of those. Okay? Only the interactive stuff. So this very last section called exercises, I might give you some of these later, but not for this week. All right, so things like, let's see if I can give you an example in here. Yeah, like this, where you can type stuff in and check your answer. Do all the interactive exercises there in chapter 1. All right, then also, go back to here. In chapter 2, so let's see what's in this one. I don't want to go that far yet. I want to see how far I want you to go into chapter 2. I don't want to overly punish you. Yeah. Through 2.2. Not very far. All right. So all of chapter 1, do all the interactive exercises, not the extra stuff here at the end. So nothing outside of the book, okay? Then in chapter 2, complete 2.1 and 2.2, all the interactive exercises. Do not do, well, I mean, if you want to go to 2.3, you can, but this is kind of, we're going to talk quite a bit about next time. All right? Questions, comments, concerns, bribes?
And implementing an insertion sort, we just looked that up.
I will give you the link to it. So here's like a Wikipedia thing that takes you through. They have like a, shows you what the algorithm is. And at the end of the day, something that's like an insertion sort.
Okay.
If you take some small liberties and do it a little bit different or something, I want you manipulating memory is what I want you to do. So use this as a baseline. If you have another sort that's pretty similar, that's fine. All right. What, my program? Maybe. All right, where am I at here? Is it, where did I put it? Is it here? Oh, it's on the other, this guy. And I'll paste this up.
That it automatically calculates the size based on the data type. So you don't need to do that I into size of.
An older compiler, you would. You would in an older compiler. So do it this way. Get used to using size of. You are right. In fact, actually, using a newer compiler, if you have an integer array or something, you can use size of to tell you its length. Yeah. So when in doubt, if you run into a situation where you're questioning always err on the side of using memory, of working with memory stuff. Because that's what I'm forcing you to do here. The sort is just the exercise I want you to do. It'll give you some practice with C doing something more than just printing crap to the screen. All right, and I'll go ahead. I gave you the link already to this on Blackboard, but I'll go ahead and I'll throw this up on Slack as well, so I'll post the code snippet here. Sample C code. So this will give you kind of a starting point. All right, cool.
How do you submit the code?
On Blackboard, so you can either paste the code up there. It's easiest if you paste it in there for me to easily read it. Otherwise, you could attach a text file. That's fine.